Hello everyone, welcome to this section, Naïve-based algorithm. The Naïve-based classifier belongs to the family of probabilistic classifier that computes basically the probabilities of each predictive feature of the data belonging to each class so as to make a prediction of the probability distribution over all classes, besides the most likely class that the data sample is associated with. It starts with a formal introduction of Naïve-based algorithm and moves on to talk about various concepts associated with Naïve-based. We'll also discuss about the working logic of Naïve-based algorithm, its different types, area of applications, advantages and limitations of such algorithm as well. We will finally conclude with a case study. A quick introduction to Naïve-based algorithm. Naïve-based used typically for probabilistic binary and multi-class classification. Given the feature vector, it leverages the Bayes rule to predict the probability of each class. It is often used in text classification, since it is quite effective method with large datasets with many features characterized by a consistent a priori probability, and it is quite capable of handling the curse of dimensionality issue. So let me summarize very quickly the working logic of Naïve-based classifier. In order to make most of the Naïve-based algorithm, we should first understand the building blocks of the algorithm. It is called Naïve-based, and by the word Bayes, we basically mean Bayes rule. Bayes rule maps the probabilities of observing the input features or attributes given belonging classes to the probability distribution over classes based on Bayes theorem, which basically helps to arrive at the posterior probability using prior probability and likelihood. We will delve deep bit and try to understand that better. Naïve, this part basically simplifies the probability computations by assuming that all the predictive features are, say, mutually independent. To put it in a simpler term, Naïve-based solution no longer restricts the probability calculations to those records that match the record to be classified. Rather, it uses the entire datasets. So, Naïve-based basically follows 4 simple steps as highlighted in the slide. At step 1, for binary response, it estimates the individual conditional probabilities for each predictor. In the next step, it multiplies these probabilities by, say, each other, and then proportion of the record belonging to a particular class of the dependent variable. In the third step, it basically repeats the previous 2 steps for all classes. And in the last step, it estimates a probability for a particular outcome, let's call it I, by taking the value obtained in step 2 for class I and dividing that by sum of such values for all the classes. Finally, one can assign the record to the class with highest probability for this set of predictor values. It might sound at this stage a bit overwhelming, but a quick example will help us iron out a lot of our doubts regarding this algorithm.